The Bavarian Chemical Triangle, a high-performance region with successful businesses and high energy demand. Coal, oil and natural gas have no future here. The businesses are planning the transformation to climate neutrality. The path towards this was investigated in the TransHyDE study as part of the TransHyDE project system analysis. The key findings of the study: the energy infrastructure for electricity and gas will have to supply twice as much energy as they do today. Hydrogen is needed as a key option for industrial businesses, and the expansion of the electricity grid must be significantly accelerated. The course for this must be set as quickly as possible so that the plans for the industrial businesses can be implemented. The Altötting district, home of important businesses in the Bavarian Chemical Triangle, one of the most important locations of the chemical and petrochemical industry in the country. Energy consumption in the district was 18 gigawatt-hours per square kilometre in 2019, 16 times more than the average Bavarian district. Planning a sustainable, reliable energy transformation is essential for the survival of the Bavarian Chemical Triangle. This raises important questions. How will the energy demand develop? Which forms of energy can meet this demand? Where will this energy be generated? How must the energy infrastructure be adapted? The businesses need the answers in order to plan for the future, and politicians need them to act. The important point is, all planning has to be demand-driven. That is why the TransHyDE study asked the industrial businesses about their transformation plans. Two pathways for transformation have been developed. The electricity path relies primarily on electrification. Physically used hydrogen is produced locally. Whereas in the hydrogen pathway, the businesses also use hydrogen instead of electricity for energy purposes, where this is useful. Most of the hydrogen is imported. In both cases, fossil natural gas is gradually being replaced completely. The processing of mineral oil as a raw material is greatly reduced. This will also significantly reduce CO2 emissions, from 2.1 megatons per year today to almost zero. What happens if we follow the electricity path? The demand for electricity increases significantly by almost 3 times. The electricity grid has to be expanded massively in order to cope with this. That takes a lot of time and is very costly. The dependence on the electricity grid is very high. It also becomes clear that renewable energies must be expanded very fast in order to meet the demand for CO2-free electricity. Let's take a look at the hydrogen pathway. From 2030 onwards, significant quantities of hydrogen will cover part of the energy demand. To achieve this, the region must be connected to a German and Europe-wide hydrogen network to guarantee secure supply. Since existing pipelines can be used for this purpose, it is faster and cheaper than expanding the electricity grid. An expansion of the electricity grid is still necessary, but to a lesser extent. In comparison, the total energy demand of industrial businesses in the region is 1.8 terawatt-hours per year less in the hydrogen pathway than in the electricity pathway. This higher energy demand of the electricity pathway has to be transported to the region through the electricity grid. The hydrogen pathway offers more flexibility and existing gas pipelines can be used for its transport. However, the hydrogen market also needs to be established first. These results are important indications for the project partners on how the energy transformation can succeed. The Bavarian Chemical Triangle is one of the regions where the success of the energy transformation will be decided in the coming years. Important steps for the success of the region are: first, the climate-neutral chemical triangle needs an implementation concept. Second, the production of renewable energy and hydrogen must be expanded quickly. Thirdly, a suitable infrastructure is needed quickly for electricity and hydrogen. The transfer-in study has illustrated these points and thus made an important contribution to the energy transformation in the Bavarian Chemical Triangle.